Hi everyone. Now I'm going to explaining in this session about how charge will distributes. Charge distribution. So if any conductor is ionized, what I said, if any conductor is having energy, the energy will travel, electric field will travels through the all the directions, the three-dimensional view. So this charge distribution is in what shapes in this session we are discussing. So charge distribution is in point form. First one, point form, point form. And second, charge distribution is in line form. Line form means line charge distribution is called line charge distribution. So this we can define with the line charge. Third, surface charge. Surface charge means charge maybe it occupied in certain shape of surface. So that's called surface charge. And next fourth one is volume charge. Volume charge. So if you think about point charge, means point charge. So point formation, the charge is very small, so that we can't define that magnitude. It is negligible, so we can't define the point charge magnitude. At any point, we can say simply what the charge is different with the differential Q dq. So that magnitude we can't define for the point charge. And next, if you think about line charge, which charge will be sometimes charge will form line like line shape means to understand this. If I take any one line having length and if it is charged, it's a positively charged. If it is charged, if it is charged, the line the total length of the line I think some L kilometers. And at any particular point, so the length of the line is L here, total length. At any particular point. So what is the length here? We can say this is called the differential length, notable letter and delay. And at that point, what is the charge? So total charge is Q. So at that point, the charge is dQ. The charge is dQ. Now here we can define line charge density. Line charge density at that point, denoted by delta rho L, which is equal to dQ by dl, dQ by dl. So for this we can define dQ is equal to rho L into dl. If I want to calculate the charge for this entire length, so we can integrate this with respect to line. So line integration I have to do, line integration of rho L into dl, rho L into dl. So this Q also we can calculate by using formula as rho L into length of the line. Length of the line. Length of the line. So length of the line. When we have to use this formula? We have to use this formula for uniform charge distribution. Uniform charge distribution. If you take any point, the charge distribution should be simple. It's called uniform charge distribution. For the uniform charge distribution, this rho L charge line charge density is constant. This line charge density is constant for uniform distributed charge. So next, the third charge distribution. Third one is surface charge distribution. Surface charge. So to calculate surface charge, we define surface charge density. Surface charge density denoted by letter surface charge density denoted by letter rho s. So now let us assume some surface is nothing but what? A closed line. It's nothing but open surface. See, it is charged, positively charged. If it is charged, it means this entire surface is at any one particular point. It was charged. So at that particular point, charge is dQ. At that location, the surface is ds bar. Surface is ds. So at that point, charge density, surface charge density we can define as rho s is equal to dq by dx. So from this, dq is equal to rho s into ds bar. Ds law. So Q, if I want, means I have to integrate this surface integration of rho s into ds law. This formula we use to calculate surface charge for a given surface. If you know the intervals of surface. So this formula you can use another formula as charge is total charge is equal to surface charge density into surface area. Surface area. When we can use this formula is say charge distribution is constant. If charge distribution is constant, we use this formula. Charge distribution is constant. So if charge distribution is constant means surface charge density is also constant because it is uniformly distributed throughout the surface of the assumed surface. So this is about the surface charge. Next, volume charge. Volume charge. So volume charge we can define with volume charge density. So volume charge density. Volume charge density. Density is denoted by beta rho suffix v. So let us assume the volume. This entire volume is chargeable. This entire volume is chargeable. So assume it is chargeable positively. Positively charged volume. So in this, the total volume is V coulombs per meter cubed. Surface charge density also different formula has coulombs per meter square. The surface charge density. Line charge density units are coulombs per meters. Coulombs per meters. Now here, for any particular point, this volume differential volume. So denoted by letter dq. Any one particular point dq. So at that point volume is dV. At that point volume is dV. Now we define volume charge density as rho v is equal to dq by dt. So from this q is equal to volume integration of rho v into dt. Use this formula. And also, if our charge density is constant throughout the value, so charge is equal to volume charge density into volume of the given medium. Volume of the given medium. The unit for volume charge density is coulombs per meter cubed. Coulombs per meter cubed. This is about the charge distribution. So on this one problem, simple concept. The problem given is the charge density is given as the charge density given as rho v is equal to 4 by 3 cos square theta into sin square phi by r square into r square plus 1 coulomb per meter cube. Coulomb per meter cube. Then find the total charge. Then find the total charge. Then find the total. Then find the total charge in the region. 0 less than r less than or equal to infinity and 0 less than theta less than pi, 0 less than pi less than or equal to 2 pi in this region. So the region is given and the charge density is given. Then examiner asking to find the total charge density. Total charge is asking means he given row, the ranges are given, ranges of r comma theta comma phi are given, and the example asking to calculate charge. So volume charge is related to volume charge density. How we define volume charge density? Rho v is equal to dq by dv, dq by dv. So you have to calculate charge here means dq. How you define dq is equal to rho v into dv. So from this v is equal to what? Volume integration of rho v into dv. So volume is related to what? It's a three-dimensional figure. We discussed already. Line is one dimensional, one directional. So single integration, and surface area double integration because it's a 2D line, two-dimensional line, and the volume is three-dimensional view, 3D view. So we have to do triple integration. So given axes are what? R comma theta comma phi. If r theta phi are given means we can say it is related to cylindrical coordinate system. So given system is cylindrical coordinate system. If it is a cylindrical coordinate system, so we have to use those ranges given rho v. So we have to calculate charge. Total charge is equal to volume integration of given rho v is what? 4 by 3 cos square theta sin square pi by r square into r square plus 1 into dv. So we have to integrate volume integration. So first we have to calculate dv. dv is nothing but what? A differential volume. You know the expression for differential volume. So this is not a cylindrical system, it is a spherical coordinate system. Spherical coordinate system. So volume integration. So dv we have to calculate differential volume for a scalar quantity. Differential volume for spherical coordinate system is dr into r into dr because related angle into r sin theta into d theta, or r into d theta here, d theta r sin theta into d phi, r sin theta into d phi. So I can write as r square sin theta into dr d theta d phi, dr d theta d phi. Now we substitute that value in the charge expression, and if we did volume integration, we will get the total magnitude for charge. So that we write again q is equal to volume is for triple integration of 4 by 3 cos square theta sin square pi divided by r square into 1 plus r square into r square sin theta dr d theta d phi. See here, r square both can cancel out. This r square. So if we written separate integration for each and every axis because ranges are given. So ranges are given. First I am going to writing r terms. Q is equal to 4 by 3 is constant. R terms are there here what? 1 by 1 plus r square into dr from the range is 0 to radius infinity into next theta terms. Theta variation 0 to pi cos square theta into d theta, and the pi variations are 0 to 2 pi. Here is cos square sin theta is also there into sin theta into d theta 0 to 2 pi sin square pi into d phi, sin square pi into d phi also equal to 4 by 3 0 to infinity 1 by r square into dr. 1 by r square into dr is nothing but what? It is tan inverse r, tan inverse r from the period 0 to infinity to into 0 to pi cos square theta into sin theta. So integral cos is nothing but what? Sin theta. Integral cos is nothing but sin theta. Means it is the form of f of x whole to the power of f of x whole to the power of n into f dash x. So we can write this as f of x whole to the power of n plus 1 by plus f of x whole to the power of n plus 1 by n plus integral sin and cos is nothing but what? Sin theta. So this I'm writing correctly. So cos cubed theta by 3 from the period 0 to pi. From the period 0 to pi. Next, sin square pi from the period is what? 0 to 2 pi. See, I'm writing here integral 0 to 2 pi sin square pi into d pi. This is called a symmetric function. Why symmetric function is because if we apply the theta 2 pi minus pi 2 pi minus 0 2 pi minus pi sin 2 pi minus pi is equal to sin pi square into similar sin pi minus theta also we can write as sin pi sin square is there. So sin means whenever you are getting that like this 2 pi are half of the region. If you are getting the same magnitude means we can say it is a symmetric function in mathematical. So to simplify this symmetric function mathematically, we can write this function also as 2 into integral 0 to pi sin square pi into d pi. Sin square pi into d pi. So again symmetric function like this. Why? Because sin square pi minus 0 sin square minus 0 is also sin, right? Again symmetric optimization. So this also we can write as 2 into integral 0 to pi by 2 sin square pi into d pi. Sin square pi into d pi. Next, now we have to simplify this. To simplify this, if we elaborate it by using binomial functions, we can write this 0 to pi. We can write this as 0 to pi by 2 sin square theta into d theta. Sin n power theta into d theta. We can write this as n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4 up to the infinity. At the end, if you are simplifying, at the end, if you are getting 1 by 2, that we have to multiply with 5 by 2. Otherwise, no need to do any calculations. So this formula, this mathematical formula I am going to using there. So with that formula, I am going to write this as 2 into sin to the power of 2. So 2 minus 1 by 2. 2 minus 1 by 2 is nothing but what? 1 by 2. So 1 by 2 came in. 1 by 2 came in. So we have to multiply with 5 by 2. So 5 by 2 multiply means this value becomes cancel out. So we can get another magnitude here as which is equal to 4 by 3 into tan inverse infinity tan inverse r. Tan inverse of infinity is nothing but what? 90 degrees. So 90 degrees. Tan inverse 0 is nothing but what? 0. So tan inverse 95 degrees is 90 degrees. 90 degrees. 0, 90 degrees. So to convert this into radius, we have to multiply with 5 by 180. 180 into cos cubed 1 by 3 cos cubed pi. So cos cubed pi is nothing but what? Cos cubed pi minus cos cubed 0. So cos cubed pi is nothing but what? Cos 180 minus 0, which is equal to what? Minus cos 0 minus 1 minus 1. So minus 2. This is minus 2. This is here. Differentiation if we did different cos of difference is minus sign. So multiply both sides with minus. So that time this minus will get cancelled out. into pi into pi. Now 1 times 2 times pi by 2 is 2 will get cancelled. So finally you can get the magnitude of charge. The total charge magnitude is as 4 pi square by 9. Q is equal to 4 pi square by 9 coulombs. 4 pi square by 9 coulombs is the procedure to solve this type of problems. We will think about another problem, the same charge distribution. The charge density is given as. So here also I am asking to find the volume, to find total charge. Find total charge if charge density, volume charge density rho v given as 10 into z square into e to the power of minus 0.1x nano coulombs per meter cubed with the ranges of x varies from 0 to 2, y varies from 1 to 2, and z varies from 1 to 3. Z varies from 0 to 3. Sorry, not 1 to 3, 0 to 3. Then examiner is asking to calculate volume charge density. So if ranges are given, the function is given. So what function is given here? Volume charge density. Volume charge density rho v given as 10 into z square into e to the power of minus 0.1x nano coulomb per meter cubed. The ranges are given. So means the given system is what? The given system is Cartesian coordinate system. Given system is Cartesian coordinate system. So the charge expression is equal to Q is equal to volume integration of rho v into dv. So rho v is given, dv is nothing but what? A differential volume. So differential volume we have to calculate. So given system is what? Cartesian coordinate system. So for the Cartesian coordinate system, coordinate system, differential volume dv is equal to dx, dy, dz. No direction. Why? Because volume is a scalar quantity, so no direction required. This volume is a scalar quantity, so all are lengths related. That's why we no need to do. That's why we don't need to specify. We don't need to specify the direction. So all our lengths means the only differential lengths we will consider. So that is the expression for differential value. If you substitute it there, you can get total charge is equal to volume in that but what we discussed. It is a three-dimensional. It means triple integration of 10 into z square into e to the power of minus 0.1x into dv is dx, dy, dz. Now, if we separate it, here x terms are there, z terms are there. So, first time we are separating x terms. X range is given from where 0 to 2 to 10 into e to the power of minus 0.1x into dx and integral 1 to 2 into 1 to 2 into 1 into dy into integral 0 to 3 z square into dz. If we integrated this, you can get the final charge value. So my charge will be e power minus x into the power of minus 0.1 0.1x divided by minus 0.1. 0.21, and the range is given 0 to into 1 is nothing but 1 only. 1 to 2 means 1 it is, and z cubed by z cubed by 3, and the range is 0 to 3. If we simplify, we will get the total, the charge magnitude. We get here the charge magnitude. So we have to integrate this to simplify, which implies the charge is equal to, so integral e power minus x which is q is equal to 10 into e to the power of minus 0.1 into 2 minus e to the power of minus 0.1 into 0 divided by minus 0.1 into 1 into 1 by 3 into, if we integrated, 3 cubed. 3 cubed is another what? 27. So 3 ones, 3 nines. 3 ones, 3 nines. So this is minus 10 in 1 by 0. Here minus will come. So that minus will get cancelled. So 10 by 0.1 is nothing but what? 100 into, I can write this as 100 into e to the power of minus 0.2 minus e to the power of 0. E to the power of anything to the power of 0 is nothing but what? 1. So by 1 into 9. So it implies 900 into e to the power of minus 0.2 minus 1. So by using calculators, you know how to calculate in the power of minus 2. So finally, if you simplify it, you can get the total magnitude here as the lifetime magnitude value 163.14 is equal to 163.14 nanocoulombs. 163.14 nanocoulombs. That is the procedure to solve this type of problem. Not only this problem, any problem is given in the coordinate system. So that we have to solve by using this procedure. So discuss the systems of three types. Those are Cartesian coordinate system, cylindrical coordinate system, and spherical coordinate system. These are the coordinate systems. So on this, once again I am repeating this problem because it is a previous exam model problem. The general any problem given here in this problem, examiner asking to find the total charge if the given volume charge density as 10 into z square into e to the power of minus 0.1 x nanocoulombs per meter cubed. With the ranges given, x is varying from 0 to 2, y is varying from 1 to 2, and z is varying from 0 to 3. In this range, we have to calculate the charge. So given volume, in the volume, how charge is going to be varying, these reasons we have to calculate. So by seeing these axes, we can say the given system is a Cartesian coordinate system. So for the Cartesian coordinate system, the axes are what? X, Y, Z axes. So all are length related, means if you define expression for differential volume, you won't get any extra coefficient terms like in cylindrical and spherical. So direct differential volume is nothing but dx, dy, dz. There is no directional vector. Why? Because volume is a scalar quantity. We can represent only the magnitude. So to get this charge, we have to volume integrate the given volume charge density. So volume charge density magnitude is given, and the differential volume is dx, dy, dz. So with this, we can write calculate charge is equal to the x. I separated x, y, z terms. After separating, we have to integrate. So by separating, we have to integrate. After separating, if we integrated, the charge magnitude we can get 163.14 nanocoulombs. 163.14 nanocoulombs. That is the procedure to solve this type of problems on charge distribution. So any problem is given, almost examiner will use the same model. So discuss two problems, one with spherical coordinate and another with Cartesian coordinate system. So few more problems I solved in the material with the cylindrical coordinate system also. You go through those and you practice.